And we're live. Oh, that's a lot of stuff. Too much. There we go. And we're live. Hey, everyone. Thank you so much for joining us for On.NET Live. My name is Cecil Phillip. And, on this show, we talk about a lot of the cool things that are happening within the .NET ecosystem. And today I have a very special guest that's joining us today, Mr. Ian Cooper. I've actually wanted to have you on this show for a very long time. So I'm kind of glad that we're able to find some time and kind of work this out.
You kind of finally made it happen, haven't we?
Yeah. So why don't we start off with just, having you introduce yourself a little bit and letting folks know who you are and what do you do?
Okay. So my name is Ian Cooper and I'm in London in the UK. And I currently work for a company called Just Eat Takeaway. So we do food delivery mostly around Europe, Australia, etc., Canada. Where I'm a principal engineer, and I tend to look after a lot of how we do events messaging, how we do our HTTP APIs, and basically how parts of the system kind of talk to each other. Background before that, I've been in a variety of places, startups, was one previously called Huddle, insurance companies, medical companies. And I guess since probably the early noughties, I've been primarily focused in .NET landscape. Prior to that, I was kind of C++ on Windows. So that's kind of my potted history.
Yeah, I know, prior to you coming on, I used to watch a lot of your NDC videos. I remember you used to cover a lot of topics like service discovery, different types of architectural patterns, ports and adapters. I think the first time I heard about ports and adapters was from one of your videos. Okay. And yeah, I'm definitely looking forward to us kind of diving into some of those topics today. But before we do that...
Also, I think probably some people may know me from a talk I did a few years back, TDD, Where Did It All Go Wrong, when we talk about test-driven development.
Yeah. Right, and then you also have some open source projects. I know you work on Brighter, and I think there's also its counterpart Darker, and there's some other projects you work on as well there too, right?
Yeah, exactly.
Nice. So before we actually start diving into the topic, what I want to do is I'm going to share my screen and just cover a few updates to some stuff that's been going on lately in the community. Okay. So first, let's start off with actually just today. Is this today? What date is it today? today. So today we just published this video on building microservices with Thai. And so we had some folks from the Thai team come on, and they talked to us a little bit about, what is Thai, what is the motivations behind of it. They showed us how we could deploy to Kubernetes and, all of this stuff that we could do without, having to write any YAML or know too much about how that underlying system works. I think that's really cool because I know me, I have feelings about YAML and having to write it. So definitely having some of these types of tools to help generate that stuff is really cool. Another thing that happened earlier today, I believe, we also announced Preview 2 for .NET 6. Now, if I'm not mistaken, .NET 6 should come out a little bit later this year, around like that November timeframe. And so now we're getting like the second preview of it. And, if you're unfamiliar, .NET 6 comes with support for things like Maui and, there's updates to ASP.NET Core, updates to Entity Framework Core. So if you're interested, definitely go ahead and download the preview, check it out, install it, and play around with some of these preview bits and let us know what you think about it. And last thing that I want to mention, so here on .NET Live TV, what we're trying to do is every month we're going to have like a theme. So last month's theme was on Web API. This month's theme is on microservices. And so we're going to have a Learn event on March 26th. So you can come over here to letslearn.net and, you could register for the new event that we're going to have. And again, it's going to be about microservices and why they're important, and we're going to kind of go through some Learn modules to kind of see how those work. So if you're interested, definitely recommend you head over and check those out. I'll share the links inside of the chat too. So if folks want to go ahead and take a look, we could go ahead and do that. All right. So now that's enough for me. I will no longer be sharing my screen today. But what we're going to do now is we're going to head over and Ian, we're going to kind of give you the floor, right? So
okay, cool. Yeah.
I think the first thing I kind of want to talk about is, so let's kind of frame like this microservice thing a little bit, right?
Mm-hmm.
Now, I know you probably worked with distributed systems for a while, right? That's kind of what I know you for, right? Distributed systems and patterns and things of that nature. And, I kind of feel like people don't really know about some of the really good patterns that we could start using, but instead we start to reach for, buzzwords. We start to reach for things like containers and Kubernetes and Dockers and all of the tools, without really understanding like what exactly we're trying to do and achieve with them. So what I really want to talk to you about today is probably like some of the best practices, some of the things that you've spoken about in the past that make it, kind of make that distributed system architecture, make it make a little bit more sense for us.
Okay. Right. So what I may do is jump between kind of various slide decks for you that I use in various presentations for you folks, and then that way I can kind of give you highlights of bits and pieces that I quite often talk about.
Yeah.
Maybe one thing to frame early on, if I get a deck up, and then you can tell me whether you want. I may not necessarily present the deck. I may just basically pick up a couple of slides, and you can tell whether it's not going to work, is it? I'm going to present that deck, aren't I?
Yeah, sure, that's fine.
That. Let me just make sure that's going to. Okay, let's.
Right, and then let me know, and I can pop up your screen on the.
Try that.
Your slide on the screen.
So I think one thing to understand that I like to talk to people about, first of all, is there's a kind of a microservices exploit distributed systems, but you can be distributed and use lots of the value of distributed systems without necessarily getting into microservices. And you may talk about this, I guess, or may talk about this in the past, but where the kind of microservices as an idea come from. And really this diagram, there's a lot going on, but don't worry about that. It's kind of where they kind of originate. And this idea here that we talk about is that when you have kind of a monolith, if you start to have multiple teams as your organization begins to increase in size, one of the problems you tend to hit is what happens when someone wants to do a release. And the problem is that, say the first team in this diagram, the top one, wants to do a release. They say, okay, we're going to release the software. We want to take control effectively of the master branch. We want to basically say, don't everyone else check in right now. We're going to basically take a cut from that, and then we're going to try and ship that out. What tends to happen, there's a reason why this happens, and we'll get into it. It's a kind of a vicious circle. Other teams then say, oh, no, we'd like to be part of that release too. And we get in on that. So eventually you have a few meetings and everyone agrees what's going to be the content of this next release. People are then effectively then cut the release, and then now because we've merged several teams' code, one of the things that now happens is we have to say, let's regression test everything in case we've broken each other's code. Then I don't know if you've ever been through this yourself. What happens then is, if, of course, you find a few bugs. Those bugs may have been there even if nobody else had checked in. And we kind of play what I'd like to call pin the tail on the donkey, because everyone has plausible deniability about whether it's their bug. So some poor soul usually gets charged with figure out whose defect this is. We then essentially go through this whole loop of triaging, fixing defects. Maybe if it's bad enough, we talk about rolling somebody's contributions back out. Maybe we've got feature flags. We can try and just turn them off and suppress them. But quite often this process ends up, in my experience, it seems to be about a 2-week cycle you go through. And because that takes so long, what happens is that by the time it takes 2 weeks to release every time, next time we want to do a release, everyone's kind of like, I better be in on this. Otherwise, I'm going to be a while before I can release. And so really what microservices is about was saying, is there a better way of doing this such that we can liberate all of these teams so that they can work independently of each other? That's really the bottom line about what the whole microservice is about. And that's why quite often you'll hear people say, microservices is about scaling your organization. Okay, it's not necessarily about scaling your software, it's about scaling your organization.
And so we have some few folks in the chat that are asking if you can make the slide deck a little bit bigger for them.
Yeah, absolutely. I'm sure I can. And you can tell me if that works for you, okay? Is that good?
Yeah, that should be a little bit better. Thanks.
Okay. So the idea is essentially that you split the software up into a number of individual parts. My team or your team works an individual part, and we are in control of the ability to release our part. And that means we can essentially go from this kind of 2-week cycle to, hey, I finished this user story. It passes all its tests. We're going to do a brief regression and we're going to ship it. And you can actually ship them multiple times a day. And that's really why everyone got into microservices. But that means a number of things. Well, let me skip through here to this slide. Okay. So how do I achieve that property that I want to build a service that is independently deployable from other parts of my application? So I would argue that microservices are an evolution of ideas that began a long time ago when we were all building distributed systems of COM and CORB, and then we got into SOAP and web services, which you can think of as service-oriented architecture, or SOA1, and it went through various iterations. But this diagram, which I think originally may have come from Don Box and Microsoft, defined this thing called the Four Tenets, and they get rephrased by different people. Amazon have kind of reframed these in a famous Jeff Bezos email. You hear Sam Newman, if you know Sam, he speaks a lot about microservices, talk about some of these properties with slightly different names. But the Four Tenets still kind of hold. And they say boundaries are explicit. What that means is to talk to my microservice, I'm going to have an API. And when we say API, that doesn't have to be HTTP. It could be messaging, right? So it could be something like AMQP or MQTT or another protocol. But some kind of API that I expose that says you have to cross this boundary to make something happen with my software. So Jeff Bezos famously talks about this in the Amazon email, saying you will have an API, and no one, particularly this is an important point, can touch any data in your database. Right? They have to go via the API to do that. And we also say, hey, these things are autonomous. And what we mean by that is they run separate of other services. They can be deployed entirely independently. So we want this kind of idea that they're loosely coupled to other services. We say we share schema, not type. What we mean by that is we don't share, say, a .NET assembly to be, hey, here's how effectively you use the types that relate to my API. We say you should be sharing something like JSON instead, because we can describe those in a neutral format, because somebody else in the org might decide that they're not going to use .NET, perish the thought, but maybe they're using JavaScript or something, or TypeScript, and they want to talk to us. So they need something in a format they can talk to. In fact, by policy is kind of less used, but it kind of says when you talk to my API, you're going to basically authenticate yourself using OAuth, right? These four tenets are quite important to understanding how microservice works, I think, because they tell us a lot about how we become independent of others. Now,
Yeah, and I think when it comes to, so you talking about those boundaries, I
yeah,
think that's the part of it that a lot of us have a hard time with, because
mm,
again, like how micro is your microservice, right? Kind of like when people were just getting into big data, like how big is your data to have big data? And
right,
so I know a lot of folks struggle with trying to figure out, well, what's the boundary that I cut this off at? You know what I mean? Like
yeah.
how many things should this, domain be responsible for in terms of like how I want to scale it, in terms of how I want to segregate those teams, in terms of how I want to like kind of position that architecture within the entire system.
Mm. So one of the things that we can do for that is start talking about dividing up the domain into it tends to be basically this idea of a process. Now, I'll step back a bit and kind of run that through for you. If I think about the kind of things that a customer does when they use my software, they come along and they give me some inputs and they want some kind of outcome. And generally, when I think about that, I may be able to usually divide that up into something like, 3 to 7 odd kind of significant steps. And each one of those steps, what I'm looking for is this notion of a handover that says there's some inputs, there's some work done, and at the end of that, there's some kind of output. So thinking of kind of my current industry that I work in terms of food delivery, right? We can think about what's happening as a number of kind of process steps. You come in, you choose some food, right? And let's assume we're at the point where you've pressed a button, made your order, and we have it at the back end. Right? So we think about the process of delivering food to you. What tends to happen is there's a bit where the restaurant's making the food, and at the end of the process, they've got some food all bagged up, ready to go, right? That's kind of a process. It's got some kind of inputs, your order. It's got some kind of outputs, which is basically the food sitting in a bag. In between, there's someone working away. Right? That's a good thing to have as kind of a step. The next thing we might have as a step is then, well, a courier is going to come. They're going to basically come into the restaurant. They're going to pick up the food. They're going to probably load up their bike or their car, and they're going to, set out on their journey towards destination. That's a pretty good step because it's essentially got a nice defined input, which is kind of the food I'm picking up from the restaurant location. It's got a nice defined output, which is me saying, message saying, kind of I've got the food, I'm on my way. Let the customer know I'm driving over. Okay. There's another step, which is really the driver en route, right? Heading towards your destination. And at the end of it, you've got a nice clear marker for a point which says, hey, I've reached the destination. I'm outside the door. I'm at the customer's house. And then finally, you've got a kind of handover, right? I give the customer the food. New state is food's been delivered to the customer, hopefully a happy customer. So what I've done is divide that process up into a number of key steps. We tend to call them processes, and you can get fancy techniques like, value stream mapping from kind of Six Sigma and Lean to help you model that. You could, if you're a fan of things like domain-driven design, you can go and look at a technique called event storming, which will help you model those kind of things. But you can also just do it by kind of talking about it with a whiteboard and everyone else on the team. And those steps are kind of useful because they tend to be able to be described as something like a verb plus a noun. So usually there's I'm doing something to a thing. And as a result of that, there's kind of like a transformation has happened. So I'm, preparing your food. I am collecting the order. I am delivering to the customer. I am handing over to the customer, whatever, right? And so you can usually pick those things, and they tend to be really good starter ideas for saying each one of those is potentially a microservice, each one of those processes. Now, one of the things we really want to do is try and get a team owning a microservice. So one of the things we may do is look at how many teams do we have, how big are those units of granularity that were those process steps. We can delve down a little bit more if we needed to. If we had a lot of teams, we could say, well, what are the activities? Are there any distinct activities in that process step, right? In that first step about, picking up the food, is there one for cooking, one for packing the food? Maybe if I need more teams involved, I can split it down into those two parts. But generally, that process model is a good first step. And then you can say, well, each one of those is probably a microservice. Now, the nice thing about the input-output model we've described there is you're clearly quite independent of it. And this is where we get into the notion of request-driven architecture versus message-driven architecture or event-driven architectures. Because that independence lets you build something that might use events over requests. And maybe we can talk about that just a little bit. I've got some stuff in here that talks about that in a second. Just I assumed it was like about 4 slides and I'd be able to get there quite fast, but
you got a lot of slides on this content, man. Jeez.
It is actually part of some training I give. I do some kind of workshops people train.
Right.
So a request-driven architecture look like this, right? So this example is actually what they call the guest lifecycle at the hotel. And a request-driven architecture, which is what we tend to quite often arrive at when we're building this kind of microservice model. In a request-driven architecture, what tends to happen is when we break up the service that we kind of started with, or the model that we started, we think, oh, well, this thing was a call that I made kind of in process between these two parts of my code. So I'll just replace that with, say, an HTTP or gRPC call to now I've split it out into a separate service straight across. So if originally what was happening was something like I was coming in, taking a direct booking here for my hotel of our website, and I've got that booking in, and I might say, okay, I'm going to run through some things. I'm going to figure out with the housekeeping system whether there's rooms available. If there is, and you're a customer that's logged in and you've already got your credit card details, we'll take your credit card details, we'll take a payment, and we'll tell channel managers, which are things like sites like booking.com, Expedia, etc. We'll tell them basically that, to reduce the number of rooms available. And it seems really easy to build this request-driven architecture that says, I'm just going to replace those in-process calls with just out-of-process calls here. But the problem we hit is that what happens if, say, the channel manager is not available, right? If for some reason I try and talk to that, maybe there's been a bad deploy by that team and it's not available. That tends to mean I can't run anything because my system is waiting for the call to channel manager to return before it proceeds on with the next step. And channel manager is not so bad here because I could theoretically say, well, I don't need channel manager. Maybe later on I'll figure out that we've overbooked. But that's fine. But it's right at the end of the line. But what happens if this was on account and I said I need to get hold of the customer's credit card details from the account system and it was down? Well, I can't take your payment. What happens if the payment system is down right now? If I'm talking to a payment provider and it's not available right now, right? Which, like that doesn't ever happen. I could have bought the whole transaction for the customer, and I really kind of want their booking, right? The other problem we have, so you see, there are ways around that. I don't want to get into those in this session. That's what really proxies and more than one are, unless we get into what are service meshes. The other problem we get with this kind of request-driven models is what happens if I want to break up housekeeping? I've been really successful with my software, and it turns out everyone loves my housekeeping functionality, and I want to go faster. So now I've decided I'm going to break up that microservice into some smaller things that represent some of the activities so I can get more teams working on it. But the problem is that as soon as I do that, that has a ripple effect, right? Breaking up housekeeping means that all the other services that deal with it and call it, they're also impacted. They have to change too. And that kind of defeats my model of I want to be able to just change things independently. So one of the things that process models give us a nice advantage of is we could look at doing event-driven architectures instead. And this is really where some of the open source projects I work on come from. And in event-driven architecture, what we say is, well, hang on a minute. If this is a process that has an input and some kind of output, maybe I could just make that handoff to some kind of messaging layer, a broker, and get it to just say, you know what, put a message down, anyone who's interested in can listen to it. And I'm old enough to have worked when I was at university, college, I guess some of you guys would say, for an insurance company. And I literally did this old school kind of job where I sat at a desk and I had some plastic trays, which were my in trays, and some plastic trays that were my out trays. And every morning someone would drop off a stack of work in my in tray, and I would take the top file off and I would go through and do my small part in the overall process, which usually was kind of like, filling in a few things on some forms and then ticking off that I'd done it and then move it into my outbox. And then someone would come collect my outbox and that would move into the next poor soul's kind of inbox, right? And that kind of model is kind of how event-driven systems work. You've got a kind of inbox and what's done an outbox, and the the person with the trolley pushing the files around is really basically is our broker. So, RabbitMQ or Azure Service Bus or SQS and SNS on Amazon, right? And so what I could model is I could say, well, when I get this direct booking in, I'm just going to record information in my system that I've received a direct booking, and I'm going to raise an event saying, hey, I've received a direct booking, right? And I don't know who's going to listen to that. I'm not interested. I just know that I've done my part and I've raised that fact. And then subscribers say, actually, I'm interested when one of those happens because I have some work to do. So please deliver that to my inbox and I'll take some work. So here we can see, say, the housekeeping system saying, hey, you know what? I should basically know about bookings so I can figure out whether we've, what's happening to occupancy so I can make sure the room's ready on the day, etc. I know nothing about
using something like that centralized broker and just publishing those events is how we could start to decouple those individual services from everyone else, right? Like I don't need to know where credit cards is or accounts is or whatever, but I could just say, hey, this happened, right? And then let the system deal with it.
Right, exactly. I don't know any. I have no idea about the topology of what happens downstream. I just know that I raise something and somebody else downstream is going to listen to that, right?
Right. And we have one question really quick that's a little bit related to this that's coming in from YouTube. And I want to make sure that we got to this before, before we move on. And this person's asking, I'm going to put this up on the screen really quickly. This person's asking, how do you aggregate data where it's needed between services? So it says, let's say a user administration system needs a list of all the users and you want to have the number of orders each user has.
Okay. I have some slides about that. Maybe we can just do this tiny bit and I will cover that because it's a really important topic and that's a great question.
Yeah.
All right. Yeah, I've got 2 slides more on this bit and then we'll get rid of this deck and we'll go on another deck and we will talk about quite how we do that because that is a really good question.
Okay, cool.
Okay. So you can see that if we lose something like Channel Manager, the other advantage of this approach, right, is generally what happens is we use a queue to listen effectively to the broker, and that just stores things to basically forward them to us later. So Channel Manager can just stack up those requests, right? When it comes back online, it can process them. So it means that because if we accept an asynchronous kind of flow, we get the advantage of eventually being able to deal with something eventually. And the way I quite often talk about this, that is this. Nowadays, the only person that actually phones me with voice is my mum. Everybody else just sends me a message, right, on Twitter or WhatsApp or whatever. And the reason they do that is because it's really annoying if I'm not there and I don't pick up. And once upon a time, we'd leave an answering phone message, which was kind of the equivalent. But nowadays, it's much easier to just send you something, some text to read. And so we've all shifted quite naturally towards messaging because it works better, right? If you're not there, that's all good. That's fine. You can pick it up at some point in the future. You and I, it's just like I've been playing tag, trying to basically communicate about this event. But it's a lot easier than having tried to phone me, right?
That's true. And I'll be honest with you. I'm glad that sometimes people can't get me directly, and I could just kind of have a moment. Back to you later when I have like the mental bandwidth to like respond to the message.
And kind of exactly the same is though true for a messaging system. So one of the things this also helps you do is if you have a constrained resource, say for example your database, and you've only got a certain number of connections in your connection pool, you can read messages at your own pace, so you can process them around the limitations of that constrained resource. So it also helps you scale.
Yep.
So it's the same way it helps you and I scale by saying, I don't want to take in phone calls all day. I'll just stack them up. Exactly the same thing. And in the same way, also, it means that if I change this downstream and I change housekeeping, nothing upstream has to know about that, right? It's just somebody else. It's just who's listening has changed, but it doesn't really matter. I didn't broadcast that. All right. So someone asked a really great question. So I want to shut down this deck and switch things around, and I will find I don't want to do that. The other deck, which I've got somewhere here.
You guys like some serious inception going on there right now.
yeah, I know. If I can get this one up and then just make it big enough for you before we switch.
Yeah, it's all good. And then while you're doing that, I just want to let everyone know, like, as you have questions for Ian, go ahead and just drop them in the chat, whether you're watching on YouTube or on Twitch. Go ahead, we'll be monitoring in both places. So as things come up and you want to ask a question, just go ahead and pop it in there.
Okay. let me just okay. All right. So this one's strangely compressed. I think I fixed that somewhere else. Okay, I'm going to skip that slide because we can't. I'll go through it very fast. So a reminder, what we're saying is, hey, once upon a time, I do this in a monolith. Imagine it's a module. So we've got a nice monolith with modules inside. It's well factored. We've got probably have one team at the beginning, and we become a wildly successful startup that's growing our teams. We want to use microservices. So quite often I may post it into an API. Excuse the things compressing. Post it into my API. I want to create a new booking. My direct bookings module picks that up. It says, write the new booking. Reads and writes some stuff. It says, actually, I need some account information to process this. So we read the account information, get the credit card details, tell the payment system, take a payment for this credit card. It calls out to a payment provider. We then basically go and say, hey, housekeeping, you know what? We're gonna have someone stay with us on this date. Housekeeping says, great, I'll book that in. And the channel manager system then gets decremented, right? And the easy thing was everything, we just talked to one database, right? That seems like really easy. Okay. So what happens here, right, though, is now what I've said is that the database has to live inside my microservice. So each microservice has its own database, and it has to be the writer of its own data, and you can't get to it apart from an API. Right? I think I've got a version of this deck which shows the database inside the box, the microservice, which I think is a bit clearer. So how does that work in this context, right? Because now I suddenly can't reach into your database and grab the account information, etc. So if I think about it, when direct booking comes in and I say, okay, put it on the broker things are listening. That's what I've said happens. So what happens in the case where I say, well, I want to get the accounts to give me the credit card details? How's it going to work, right? And the problem with that is I might think, well, hang on a minute. If I listen to the direct booking message in credit card payments, and I know I need the account data to talk to the account to get your saved credit card details, how do I get a hold of that when I got that message? And naively, what might happen is I say, oh, well, I'll just query the API. I've got an API, an HTTP API or something, because that's how the front end talks to this. I'll just query that same API and get the data. But the problem with this is I've now turned my lovely event-driven architecture into a request-driven architecture. Because what I've done is essentially I've gone back to this direct synchronous call. So in other words, the person picking up the credit, if imagine this in the old school desks where everyone inboxes and outboxes, if I'm the person doing credit card payments, you're in my inbox, you just come in the file with your direct booking request. I've opened it up and it says, hey, you're booking on the 15th. And I have no way of knowing how to basically take the payment. So really it's the equivalent of me now picking up the phone and trying to phone the accounts department and say to the accounts department, you know, so I hope someone picks up the phone in the accounts department. If they do pick up the phone saying, yeah, can you tell me what Dave's credit card details are? And can you just read them out to me and I'll write them down and then I'll take the payment, right? And that doesn't really, that's not the best way of handling this situation. So the question is kind of what we do to solve that problem, right? So if you think back to the kind of observer pattern, which I'm sure a lot of you kind of are familiar with, and that takes form in things like MVC, right? We have this idea that when we notify somebody that something has happened, we get two choices. The first is we say to them, I'm going to give you all the information you need to process this. And the second is I assume that you have some way of asking for that information. So we look at this diagram, we're splitting in half here. Down on the left-hand side, we're saying I've got like a payments database and a credit card payment system, but it needs to know the credit card details. So how do I get it to it? And one way is that I just include it in the message. Whatever credit card payments receives has that information. Now, it might be quite easy from the front end to do. I'm asking you to input it into a form and I take it. But if it's stored in an account, how do I do that? And we can talk about that in a second, right? The other way is to say you have a copy of the data. Your service has a copy of somebody else's data, right? We can talk about those two things because they're quite important. But choreography is a way, so most messaging systems are pipelines, and choreography is what we call it when we say, I raise an event, and credit card payments wants to listen to that event eventually and take the payment for me. But there could be an arbitrary number of steps in between those two things. And in choreography, basically, we're saying I raise an event, but somebody else listens, and I don't know who's going to listen to that. And it turns out that rather than being credit card payments in this case, what might listen to that is the account system. So you say I've got a direct booking on an account, and account says, well, I listen to that. When I get hold of that message, what I'm going to do is I'm going to basically put the credit card details into that message. And we call this essentially a content enricher as a name for that pattern. So I'm going to enrich the content of that message. I'm going to add the credit card details and probably encrypt the thing, right? And then what happens is credit card payments is going to listen for a direct booking on account potentially and say, okay, great, the credit card information is in there. And this is quite common, and people tend to miss this when we start talking about how do we solve a problem with events, is this idea that always remember you're dealing with a pipeline. You're dealing with something that essentially can have multiple steps between the point where you generate the work that needs to be completed and the thing that takes the final step for you. In between, I could have any number of things, and they don't necessarily have to do work in the sense of saying, I'm going to process this and actually, move something on. It could simply be filling out some details. So it arrives on my desk in the accounts department, and I say, okay, somebody wants the credit card details in order to complete this request. I go away to the filing system. I look up the customer's details. I find their credit card number. I write it on the slip, put it all back in the message, put it in my outbox, and wait for someone else to complete it, right? And that's a very common way of solving this problem, is to use a pipeline.
Nice. And now we do have a lot of folks. I think people are really excited about this content that you're sharing. There's a lot of chatter going on right now. The first question that I kind of want to go back and ask you was about, so a lot of folks in here are asking about Cqrs. And one person is asking here, I don't know if this might not be so much so related, but this person's asking, is it a good idea to use OData for queries and commands together, or is it hard to implement complete search query engine via Cqrs?
Wow. Okay.
That's
we can get into that. I want to show you one more thing briefly. I would show you this one briefly because it actually relates to that question, right?
Okay. Good.
And we'll get into that in a second. So ignore all these. Lots of content I appreciate we're flashing past. Don't worry about it. But I want to show you this other key part of that. A thing called event carrier state transfer, which we'll run through kind of fast. But you can find me talking about a lot of this stuff in videos on the web. So remember we had this model of a service, right? And we're getting data out of that service by basically an API. The thing about the data that comes out of the service, it has some interesting properties. It's versioned, immutable, and stale when it leaves the service, right? So what I mean by mutable, there's no point in changing this thing on the wire. It's the database that holds the master record. It's immutable, and it's versioned in the sense that we want to know how stale it is, right? So, for example, on a get, we've got some things like, when did we last change this? What's the cache control setting, right? And the interesting thing about that is the way we basically scale things like the web, we think about these being inside and outside data generally, is we can cache stuff, right? And quite often we think about GET requests, we think about caching stuff. We think about saying, hey, I'm going to cache stuff down in the browser because then essentially I reduce my latency at the cost of it potentially being stale because I can get hold of it locally. It turns out we can kind of do the same thing in messaging. I could say, well, what I could do is when you basically create an account or you update your payment details or anything like that, I'll raise an event from the account system and my credit card payment system will listen to that and it will update a local copy. This is a read-only local copy. You can think of it as a cache. It's not a master record. I don't own that data. I'm not the writer of the authority about that data. I just got a local copy that I'm updating for your events. And there are lots of ways you could build these. In the past, people at banks used to build these by doing ETL everywhere, etc. But that couples your schema and your source and your downstream system. But with events, what I can do is listen to those upstream changes to entities, build a local cache of that information. And then what happens is when I get a request for a credit card payment, I make a call to my copy of that database for the information I need to service the request. Usually quite, it's next to me, it's low latency. I get exactly the data that I want. And I am now a bulkhead because I don't care if it counts as up or down at the time, basically, that I need to service that credit card payment request. I have a copy of all the information I need to service that request, right? Now, Why did I want to cover that before we got into that next question? That's because, so I think this question, I understand where Cqrs comes in, and we can talk about Cqrs again in a second, relates more to this idea of how do I serve data, right? And let me just play this slide. So what we were showing you earlier is basically how I change data. And in a monolithic system, one of the things we might have done is have this model where over on my left-hand side there, I've got my modules like accounts and housekeeping, which are talking to my ORM and hold my domain model. We think of that as the command side in CQRS, right? I need to use the domain model. I'm mutating some state. But in order to essentially just get data out of the database, we might have a thin wrapper, kind of query layer that just says, you know what? I just want to get hold of the data and put it out basically in some DTOs via my API to go and pick up. Okay. Nice, simple model. The problem, of course, is that when I now suddenly have this world of microservices, I suddenly find that, well, hang on a minute, I want to query this service, but it hasn't got half the data it needs to give me an intelligent response back. Then we get into the world of, people talking about GraphQL and saying, hey, I want a graph basically that is actually composed of all these individual services. REST is limited because it doesn't have all the information we need, right? It isn't strictly entirely true. And we'll skip through some of these slides fast and we'll talk about some stuff. Okay, so imagine at check-in, what I'm doing at check-in is looking in the housekeeping system and I'm saying, I'm going to look at your reservation, but I want to be nice. So I want to say, hey, Mr. Cooper, hey, welcome back. I saw you stay with us last June, Mr. Cooper. Great, I've got your reservation here. So that other detail probably comes from my account. So the question is, how do I get that information at the same time? So one option is just to call both services and compose on the client, right? The other option, though, is to say, well, hang on a minute, what about that reference data stuff? I could actually add that information into the service in a cache for housekeeping. So housekeeping can then say, you know what, in order to service that request of housekeeping information, when I get an API response saying, can I have the booking details? I'll get the booking details, but I'll add in a few of those additional details that you want, like customer's full name, when did the customer last stay with us, is it the customer's birthday, into the response, right? And that's the way we kind of solve this problem of I don't have that ability anymore to join across tables in microservices. I give you a read-only copy of the data, give you a cache of it, and then you can actually do that join to enhance the information of it. Now, you don't want to go over the top on that, but one thing you can do is so this model was saying, hey, maybe I want to do some kind of reporting, right? It's not like it's essentially interactive. I want to do some reporting, and I want to look at how effective it is for me to advertise with different channels like Booking.com and Expedia. And I want to basically that to be kind of someone can go to a screen and it just shows them currently what the status is. So I can do something very similar, but I can say I'm going to build a service who's essentially has a database that's effectively just something it queries. All right. And it's built up from listening to bookings information from the channels, and we essentially build something from that data that is essentially a queryable store, kind of an online analytical processing store, if you think about it, OLAP, that says, hey, I've got the information you need to query. You don't write anything here. That information is written to those original microservices, but I've taken that data and I've built something that lets you report on it. And you can generally do this such that that model is very efficient, that you're only really getting back one row from the database at a time because I've pre-calculated most of the answers to the problems. And that model really helps you with solving this kind of problem where you get microservices have data in individual databases, but what I want to do is join some of that data to report against it. Okay. And even if I get something like GraphQL in the microservice land, a common way I might do that would be to listen to a whole load of data and build some database and stick a GraphQL over the front of that, and then let you query to your heart's content against that thing, but then rely on something like a REST interface and the other microservices to actually update the data.
Nice.
Style is going to go on, but yeah, go on.
Yeah. So I know we did start a little bit late, and you do have some code that I really want to make sure that we make some time to go through.
Okay.
So how about, like, this is all really great information, and we have a lot of folks in the chat that are saying, can we get the slides? Where can I see the slides? Do you have more information about it? So I'm
Yep.
guessing when we get to the end, we could talk to them a little bit about that, and you know,
Yeah, we can do.
'cause I'm sure you do trainings and other things around this type of topic too, right?
Yeah, and then all of my training content, the slides and everything else, it's in my GitHub repo. I make that freely available. So we can give you links at the end, I guess. To share. Okay.
Yeah.
Yeah.
So before we get to that, why don't we head over to like your editor and let's actually see how we could do some of these things in code. And in particular, I'd definitely love for you to talk a little bit about your projects, Brighter and Darker as well.
Yep. So we'll talk about Brighter and Darker. I think that's the easiest thing to do next. So, what are Brighter and Darker, and that we've been kind of talking about a little bit?
Yeah, and then could you make the thing a little bit bigger?
Yeah, of course I can.
Yeah.
I'll just move it to one side so I could see your face, while I and I'll move it back in a second.
Sure.
So what is Brighter and Darker? So if I want to do messaging, one of the challenges most people have, I think, is that how do I work with messaging libraries, right? How do I do that in a way that's easy? So I had to do this a number of times at various organizations. So I decided I'm just going to build an open source one, and I don't have to keep rewriting it for every different organization that I visit. A lot of this was built when I was at Huddle Engineering, and I was very fortunate there, along with some of my colleagues, to have a 20% time model for working on open source. So a lot of that came out of that particular shop. What we wanted to do was make it very easy to do messaging. And our model was, we want to really make it as simple to do messaging as it is to do the web with ASP.NET, right? So in the same way that I go into ASP.NET and I write a controller, and most of, all the gubbins of doing HTTP, listening to basically requests and responses, transforming them into something that looks like a typing method, that's all handled kind of for you. I do a bit of configuration and I'm there. We wanted that kind of model. We wanted to say, you're just going to write something that handles a message that you've received, or that lets you send a message to somebody else. And with a little bit of configuration, all the rest of it will work. And that's really the goal of the project. So there are two things to think about if we look at so it's on GitHub. It's Brighter Command is the name of the org. This fits your project Brighter. We'll talk about Darker in a little bit. The two key projects to care about when you to understand it are Brighter and Service Activator, right? So Brighter, you can think of I'm sure a lot of you are familiar with, say, Mediator. Very much the same kind of thing, right? It takes the command pattern idea of saying, I want to separate the caller from the code that I execute. And in fact, rather than just have a simple command object, I'm going to use this idea, have a dispatcher that says, hey, to take this command, find a piece of handler code for it, right? And we call it a command processor because it's this idea that I can do, it's a pipeline, again, in the concept we mentioned earlier, some arbitrary things in between. So here in our samples, this is kind of hello world. It's kind of the simplest sample we've got, I think. We're saying, hey, I'm going to create a command processor. There's a little bit of Brighter gubbins going on there. Don't worry about that for the time being. And a command processor is essentially saying, I'm going to send you something, which is a command, right? And you're going to take some action. And what action is it going to take? Well, if I go over here a second, let me go into the samples. Oh, well, I can get hold of this. This handler is essentially what it's going to run, right? There's a command as well, but that's kind of like, it's so trivial. Let's not dwell on it.
So your commands are pretty much just like Poco classes, right? Like they're plain old CLR types for the most part.
Exactly. Yeah. And all you need to do is you can implement an interface, but you should really derive from our request handler class. And you just have to, there's one method on it called handle you need to override. And in there, you just do whatever work you want to do in response to that command, right? And then this thing acts like Mediator. It just basically says, okay, I'll direct that. And unless we've got an attribute there as well. So the attribute is we let you put some things that are orthogonal in front of the handler. So between the request and the handler, something happens. And essentially, there's what we call a Russian doll model. It encapsulates that step and subsequent steps. So here we're just showing doing logging. What that means is it'll wrap that thing, and it'll automatically log out. I'm about to call this handler, hit with this command. And then afterwards it say, hey, I called the handler with this command. But the other thing we supported from very early on was poly. So you can wrap these in kind of a poly policy that says, hey, if this handler fails, retry it. If it fails a certain number of times, evoke a circuit breaker, for example.
So would you call those attributes, like those attributes aren't handlers, but they're just, I guess,
they are,
parts of the pipeline?
Yeah, I mean, technically, I guess we quite often refer to them as filter steps, but they're actually just another handler. They implement the same interface that this endpoint does, but they don't derive from a request handler. They derive from something slightly different. But you can write your own very easily. Yeah, I mean, and obviously there is a kind of async version, right? You can see a little bit more. We've got support for host builder. You can see there's a little bit more complexity in this one. Okay. So what's the service activated bit? Well, the other thing we can do is this by messaging. So rather than send stuff to be handled internally, we could send stuff to another process to handle. So let's look at
like a worker process or worker queues or something like that, right?
Yeah, exactly. So if I look at this example, it's not that different. Oh, okay. On the sending side, we should probably use a host builder. It's a little bit clearer, I think, an example. So there's a whole lot of configuration we do, but otherwise, really on the sending side, I'm sending basically just this message, right, with a command processor, but I call post instead of calling send. And all I do with post is the metaphor is I'm sticking inside a post box. Someone will come along, collect it, and deliver it, and that person will then receive it for me, right? And then over in the handler, I don't know about the arrangement basically here for the time being. I'm doing some work to kind of spit stuff out to a console and handle that, right? But that's happening inside this entirely separate process, the receiver. Okay. And in the receiver, I'm just setting up essentially to say, hey, actually what I want to do here is subscribe to RabbitMQ. So we've got different types of subscription, but this one's going to work with RabbitMQ, different transports we support. I'm setting up a subscription. I'm subscribing to 2 events, a greeting event and a farewell event, right? Connect interface with RabbitMQ. And what I want to do is essentially say, I'll go away and run this. And what this does when I run it is it says, I'm going to start up basically a loop. And in that loop, for every one of these subscriptions, I'm going to read the associated message queue on Rabbit. I'm going to basically, when there's a message, I'm going to take that message. I'm going to translate it into a type in your type system that you told me you want to translate the message into. I'm going to dispatch it to a handler. So this essentially takes those messages that come from Rabbit and fires them to this greeting event handler and this farewell event handler. Right? And we just support a range of transports. So as well as RabbitMQ, you can see we're doing something very similar over here with Kafka. Okay,
so I'm guessing one of the benefits of using Brighter to do something like this is that my app, or at least the code that I write, doesn't really need to know too much about Kafka or RabbitMQ or Redis. It just talks to the Brighter interface, like the API interface, and then I just rely on configuration to figure it out.
Exactly. Once all you need to do is figure out, what are the various parameters that change a little bit from middleware to middleware in the subscription that I need to set to get it all hooked up. Yep. And then really the idea that we were trying to get to is pretty much in the same way in ASP.NET. After I've kind of configured Kestrel or whatever, I don't have to worry about that too much. I just go and write controllers. In the same way, you just need to really go and write your handlers.
Got it.
So I might be able to get he said, Kafka one to run. Let me just see if I can. So I'm starting up a console window, and let me just crank up the. Whoops, what did I do there? That probably wasn't the same as the thing I really wanted to do there. Did I just close a window? Okay. I seem to have. I can do 2 windows. Then we'll just do it that way. We're sharing the screen, aren't we? We'll be okay.
And we'd gotten a question from someone earlier that was asking, how could you build a CQRS service using a web API? So I'm guessing they're just meaning how could you implement the different read and writes within like a single RESTful endpoint? Yeah. But we could probably talk about that a little bit later on.
Yeah, so something like the command side, something like Brighter or Mediator will do, right? And that says basically take the input you get in your web API controller for something where you want to modify state in some way, you turn that into a command and you pass that to basically a brightest command processor or some mediator. We have a companion piece called Darker, which says, hey, I want to wrap doing the query for you as well and make it look a very similar model. The difference is the command processor side basically says, I'm not returning a value to you. And the query side basically says, I'm giving a value back, right? But those tools will help you write that. Mediator, I think, does both in one single package. I seem to remember. It supports both kind of the command and a query kind of style syntax.
Sure.
All right. Let me see if I can get. So the first thing I just need to do is a Docker compose file. So if you look at Writer, if you just look for GitHub Writer command to find us, you'll find we tend to basically have a lot of our infrastructure. I need to go up one actually. Let me just go up one and trying to get 2, 3. Come on, where am I? Got something to that tool. I type and talk at the same time. It's never been my strong point. I am and always been somewhat envious of people who have mastered the art of typing and talking at the same time. So we supply a whole lot of Docker Compose files that let you create infrastructure. There's the master one that says create all infrastructure we use for all of our different transport, etc. Good luck with that if your machine hasn't got a lot of spare memory. We provide ones to let you spin up individual transports. So this is just going to spin up a single node Kafka cluster for me, and I can use that to essentially test this stuff locally, which is always kind of handy.
And that's all in the GitHub repo, right? For Brighter.
It's all in our GitHub repo. Yeah, the idea really behind our GitHub repo is you should be able to basically pull it down. It's just a normal kind of .NET build. There's no sort of fancy tricks going on, and you should be able to pull it down and then pretty much just run the whole thing if you need to. Okay.
Got it. And we have some folks that are asking if you can make the terminal font a little bit bigger because I can't see what you're typing right now.
Do that. Yeah, you don't need to see what I'm typing right just yet because it's just nonsense, but I will do that. Okay.
So that's not for you. You don't need to see it right now.
Yeah, that's just me fumbling with trying to get the right directories. Okay, how do those look, my friend? They look visible to people?
Yeah, that's a little bit that's a little bit better.
So I mean, what will happen is you'll just see stuff flashing past the screen, and it's kind of like it's working, but whether you'll get a lot of value by actually being able to see exactly what's flashing past the screen. So what we can do is we can spin up basically these and just to the sender. All this thing does is basically this is one of our sample apps. It just spins in a loop sending hello world messages, and the idea is just so you can see the idea that it's just basically continually sending stuff. So you should see it'll take a little bit of time just to initialize up and do a little bit of a handshake with Kafka and talk to the Bootstrap server in the Kafka cluster effectively, and then do that. Okay, and hopefully,
yeah, and kind of like what you said before, right? We don't really, we're not too concerned about like what the log messages are saying right now. But it looks like you have an exception though.
It does, because I think potentially it's saying I'm not happy talking to your cluster. Let me see if I can find out what went wrong there. Bottom of your screen. Yeah, this sometimes happens. Just to be annoying. So what sometimes happens is let me just start another shell window to fix that you don't have to necessarily worry about. Sometimes I find with the Docker container for Kafka is that Zookeeper and Kafka have dependency. They don't start in the right order, and eventually the Kafka cluster decides to give up the will to live, and so you have to kind of then run it again. So what I'm going to just do is in another window, let me
So is it possible that you could run Zookeeper first, like manually, and then execute on Kafka right after?
Yeah, I mean, usually the second time is a charm with this thing. What I'm going to do is I'll run it in another window, but I will leave that window. I won't do -D, so I won't make it silent. And usually I can then keep an eye on seeing the whole thing spin up.
Sure.
And it will usually work second time around because Zookeeper's now already running, right? So Just looking at there's tons of junk in here, but that doesn't really matter.
Yeah, that's a lot of reverse logging going on right now.
Yeah, that's actually because basically we're just coming to version 9. We've been a bit delayed with version 9 because we had various members of the team all on paternity leave.
Sure.
So paternity leave is quite a thing now in Europe, and that's great, but it slowed down our open source project a little bit. It turns out that having babies is not necessarily conducive towards doing open source. So
that's true.
Right, so you can see basically now on the left-hand side, I am producing a whole lot of messages. The thing in green is where we're sending a message. The thing there's a little blue, white and blue after it, which basically is saying sent. So there's a little bit of on a Kafka producer. It says to me, "Oh yeah, you sent the message," but it then gives me a callback when I've actually sent it. So we're just basically handling that for you, and we put that stuff in what we call an outbox. So we'll retry that if it failed for you. And then what I can do is run the receiver. So the whole lot of messages stack up. So, and of course, being queuing, I can just basically run the client and the server at entirely different times, right? Because it's just stacking up. And the Kafka is basically appending to what we call an append only log. So that receiver will start up in a second. My machine is struggling under the weight of everything here.
Sure. And then when you talk about sender and receiver, so there's one process right now that's running darker, and it's sending messages, and there's another.
They're both running brighter. One's running brighter effectively in its role as a producer. So it's basically doing command processor.post effectively. That's one on the left-hand side. And the other one's running that service activator, is what we call it, which basically is the message pump that's basically reading from that given Kafka queue and essentially then processing it. So you can see the little greeting message where it says hello 44, hello 45, right? That's our handler running and essentially spitting out a message to the console to say we're receiving it. And this will go on, forever, right? If I don't stop it.
Got
it. And you don't have to be doing microservices to do this, right? A really common use case for this is what we call a task queue. And a task queue is where essentially I take some work in on my API and I say, you know what, I don't want to try and process that in line right now, because it's going to take too long. What I'd rather do is, rather than give you back a 200, I'm going to give you back a 202 accepted. And I'm going to say, I've got your work, and I'm going to process it asynchronously, and I'll let you know when that's done. And generally what you do is in the link header on that response, you say, here's a link to a URL that you can poll, and on that URL you can either see one of two things, usually a progress indicator if it's complicated, hey, I'm at step 3 or 4 on this thing, I'm almost done. Or sometimes what we actually do is say, hey, here's the resource that I'm creating for you, and it'll be 404 until it finally exists. And then on the back end, what I do is put the message onto a message queue, right? And then a worker process reads work of that message queue and then essentially processes it at a rate I can handle. And that's a way of shifting work asynchronous to the pattern. It's called a task queue or a work queue. It's really huge in, say, Python, where people doing Django use a tool called Celery to do that. But this works perfectly well to do that kind of offloading of work to be asynchronous via a message queue. Why couldn't you just do that asynchronously inside your API control endpoint? You can, but don't forget, if that endpoint crashes, you lose any work that's currently in flight. Here, I put the work on a queue, and we won't take that work off the queue until you've completed and you've act. So once you say, hey, I'm done with the work, we act and take it off the queue. If you crash, we'll leave it on the queue, and then when you restart a new consumer, it'll pick that work up off the queue and say, it wasn't completed, so I'm going to do it.
Sure. And I also think it gives you a little bit more flexibility when it comes to scaling too, because now you have these two processes, right? The front end, quote unquote, that's the API endpoint, and then the other thing that's doing the processing off of the queue. And if I wanted to, I could scale up the processors, right? The things that are pulling from the queue more if I wanted to process that queue faster, or kind of like what you said, like if my API went offline, that backend could still be there pulling things off the message queue, and so I wouldn't have to disrupt my workflow too much. Yeah,
and we offer a couple of ways to doing that. You can either just run more instances of that console process, right? So this kind of greetings receiver console, or what we actually do is let you run multiple what we call performers. Now, I don't know if number of performers. So we let you basically change that. So number of performers just means how many threads do I want actually reading this particular channel. So you can also effectively scale up on an individual console, on an individual consumer if you want to. So we offer both ways of doing that. Once upon a time, everyone used to effectively, scale up. But now in the days of containers, we tend to scale out more because essentially I can just spin up another container quite easily to go and do that work. And it's a little bit easier for the kind of scheduler to say, hey, I want to basically introduce some more containers in response to my queue building up than to figure out basically, hey, I want to introduce some more threads in response to my queue building up. So it's easy to do that kind of automation by having multiple instances.
Got it. Now, someone had asked a little bit earlier about Dapr. So Dapr, again, if for folks that aren't familiar, Dapr stands for Distributed Application Runtime, which is a process, pretty much a process that we have that runs as like a sidecar process. And it does similar things with regards to messaging from the perspective that, you could send a message to this process and then it'll figure out what thing is going to exist on the other side. So whether that thing is Kafka or RabbitMQ or Redis or whatever, and again, you don't, your application doesn't know, is none the wiser for it. Is there anything special or any particular provisions using your libraries, either darker or brighter, to be used with Dapr, or can they just work with each other just fine out of the box?
So if you essentially want to use us alongside something like Dapr or any other kind of message, I mean, there are other ones as well, like apart from Brighter, there's things out there like Mass Transit, Rebus, etc. Usually the things you have to be aware of is what is the standard that particular framework has for what a message looks like on the wire. And by that, I mean, what we tend to do is just create a JSON body that looks a bit like the type that you're sending over the wire. You have quite a bit of control over that, though. There's a thing called a message translator, which is part of the pipeline. You can write one of those. You can intercept that step, and you can pretty much write anything you wanted there, provided it's essentially you can represent it as bytes. And we have certain message headers, most of which we can kind of substitute for if you don't provide it, but one or two which we expect. And I can't remember whether Dapr has any constraints about what appears in the kind of body, but that's usually what you have to do to get things to talk to each other. But otherwise, mostly it's pretty interoperable. You can send stuff to people out there in the wild, listen to messages using Brighter that somebody sent to them using Java, right? Sure. And that's a big win, provided we all agree what the shape of that thing looks like on the wire. That's pretty easy. Yeah. So this and Dapr are fairly solid. We don't have transport's fairly easy to write. So when we look down this left-hand side, a transport is what we call essentially this messaging gateway thing. The messaging gateway just says, hey, I talk to that thing, and that thing does messaging. So we don't currently have one for Dapr, and we're kind of 50-50 on how useful that would be. Well, our assumption a little bit is if you're going to basically use Dapr, you probably just go straight to the Dapr effectively rather than us wrapping Dapr. But what we certainly, I think you should better send from one and receive from the other. I guess the thing that we give you a little bit is in return for you being on one language platform, which is .NET, we potentially give you slightly more control at the minute about things like the message pump, etc., effectively, which is more under your control, as opposed to, say, Dapr, where effectively you just get a post coming back to you and you're less able to control the rate of delivery and that kind of thing, etc. So there's a bit more control. The penalty of the price you pay for that is a little bit more work to configure stuff in code. So some trade-offs. We've thought a little bit about, or I have anyway, about creating something which we would talk to that runs a bit more like a sidecar, but we haven't really gone too far down that line as yet. There's a really interesting, we have a library here which is pretty much otherwise unused called RestMS, and no one really uses RestMS anymore, but RestMS was a really interesting, it's an HTTP based protocol for doing messaging, kind of a bit forgotten, but I think it works really well. And I wonder whether actually when we begin to talk about running sidecars for a kind of event mesh, whether that might actually be a useful protocol for folks to look at, because it gives you quite a bit of ability to abstract away the idea of me talking to a broker that has some queues that I want to listen to in a way that still gives you a bit more control than just using kind of posts. That's my kind of hint to the team working on Dapper, that's an interesting standard maybe to look at and have see what that did in the past.
Cool. And then we'll take one more question because we are running a little bit low on time.
Okay.
Patrick from YouTube is asking, and this is specifically about Brighter. Does Brighter handle competing consumers?
Yes. So that's either this scale up thing where we do the number of performers, and each performer is effectively another thread reading that same queue, or you just choose to basically run more instances of your receiver. But either work. So if there are a couple of in some transports there are advantage to using increased performers, and that is that in some transports we can have a shared buffer. So in other words, one of your consumers says, "Oh, hey, the buffer's empty. I'm going to go away and fill the buffer." And everyone works their way through the buffer, and then when it's empty, one of them goes away and reaches the buffer. And that's really useful if you're connecting to, say, a cloud-based broker, and effectively that call to the cloud-based broker has latency, is expensive on HTTP. You don't want to get one item at a time, so you actually want to go and get a batch back, and that is useful to be able to then say, well, all of my threads can work on that shared in-memory buffer, whereas we don't have a shared buffer that works across multiple processes, right? You'd have to do something where we shoved it in a database, etc., which seems a little bit OTT. Other pieces of middleware like Rabbit MQ, it doesn't make any difference to you, because in Rabbit we can't have a shared buffer because there is thread affinity on the message that we've taken off the queue in order to basically acknowledge when we've finished with it. It has to be the same thread that acknowledges it that retrieved it from the queue, so we can't use a shared buffer. But for, say, cloud-based services, that ability to scale up by using multiple threads can have some performance advantages.
Got it. Cool. So I think we're going to stop taking questions for now. We're definitely a little bit over. So Ian, do you have any resources that you want to share with anyone before we close? How could they learn more about, your open source projects? Where can they get some of this slide content? Everyone seems to really love your slides. So let's just make sure they know where to find those things.
All right. So the best place to go and start learning about Brighter is goparamore.io. Let me see if I can. If I do.
And then as you do that, I'll also make sure to share the link in the chat.
We've got on the go. Is that working right now for me? No, hang on. What we're going to do is go to the GitHub repo, because that's what I tend to do most of the time. When I get to the GitHub repo, which is Brighter command Brighter, so you may want to do that one there as well. There is usually a link to our website. Where is our website? There we go. Okay, I put an extra dot in. But that gives you the kind of elevator pitch, and that will take you then to various bits of documentation that we have. So that's probably the kind of useful link to take away, and then you can obviously get to GitHub from here as well, right?
And then you said all your slides are on your personal GitHub too, right?
Yeah. So that's basically, if you go to GitHub Ian Cooper, I search myself rather than typing, which is awful. Even Google knows to go with presentations. This presentations folder includes everything. So those slides were from Practical Messaging Day 1, Day 2. The new ones are the latest versions of that. That's the workshop I teach at various conferences. You can usually catch me there. And then everything I do is here, even stuff that's paid for, workshops and stuff. You can get the content for free. There is also there are some exercises for this one, and they are in a repo. Some repos called Practical Messaging for a language. There's Python, there's .NET, there's JavaScript as well. Don't sync this repo, by the way, unless you're mad, because at times it's had various things in it, like video, etc., and it's like huge the presentations repo, and you'll run out of disk space. So just the GitHub knows basically about PPTX files and PDFs and binaries, and just let you download it. So you can just download that one, right? If you want to do.
Yeah, I saw like some stuff looks like you've been using this stuff for. Some of that stuff says 3, 4, 5, like a long time ago. So I can imagine it's a pretty hefty repo to kind of pull down.
Yeah, but most of my content is there. I kind of believe in sharing everything, right? I don't try and hide stuff from people, but I know that not everyone can afford to necessarily go to a workshop and see that being given in person. So I try and just make it as available as I can for everybody.
Sure.
And I'm iCooper on Twitter, ICOOPER, and my DMs are open, and I'm very happy to take questions from people.
Awesome. Well, Ian, again, thank you so much for coming on, and then thank all of you folks for watching. Like Ian said, if you have any questions for him, feel free to reach out to him on Twitter, and then we've shared all the GitHub links inside of the chat. And then if you're watching the recording of this, then definitely take a look in the description. I will have the links available in there as well. So again, thank you all for watching, and we'll see you next week as we continue Microservice March here on .NET Live TV. Bye, everybody.